Let's see other problem based on graph data structure. So today problem is find if path exists in graph, and it's an easy problem. Let's understand the problem and then we'll jump into the code. So it's saying like there is bidirectional graph with n vertices. So you can take this example, 3 vertices, where each vertex is labeled from 0 to n minus 1 inclusive. The edge in the graph are represented as a 2D integer array. So that's the edge. So if you see edge here, it's a 2D array. Okay, every vertex pair is connected by at most one edge, and no vertex has an edge to itself. So let's analyze this example. This is bidirectional graph, and if you see here, there is a edge from 0 to 1 and also edge from 1 to 0, so from both direction. So in this example, if you see here, like each vertex has 2 edge. So 0 has 1 edge, and here another one 2. So 0 to 1, 0 to 2, and 1 goes from 1 to 0, 1 to 2. So every vertex has 2 edges. So in this example, if you see n equal to 3, that's a number of vertex, and edges is, it's saying this is like 0 to 1. That means 0, it goes, the edge goes from 0 to 1, 1 to 2, so 1 to 2, and 2 to 0, 2 to 0. And in other way also, if you see, like you can say 0 to 1 or 1 to 0. Okay, so in this case, like the another input is source is 0 and destination is 2. So our requirement is to return true if the path exists from source to destination. So we know the source is 0 and destination is 2. So there is a path from 0 to 2. So in this case, we have to return true. So that's the requirement. Okay, so in order to code this, first we have to create this graph in a map. So the idea is, in a map we can store, like we can say 0. So 0 will be the key, and from the 0 will be key, and from the 0, what are the other vertexes? That's the edge. Like from this, the vertex is 1 because there is an edge here, and another vertex is 2 because there is an edge also from 0 to 2. So in a map, we'll create integer as a key, and as a value we can store this 2, so that will be array. So that's the strategy we are going to use here. So in a map, we'll store this graph first, and once we have the graph ready, then after that we traverse like breadth first search. So first we'll take 0 and we'll come here, then again we'll take 1, we'll come here, and we'll come here. So we'll also use another data structure queue here. So it's a breadth first search, and we are going to use queue data structure also. So first create the graph and see how it works. So, and before that, like we can check a condition, like if the source and destination same, so that means that's a true. So source is 0 and destination is also 0, that's a true. So for that, I can check a condition if source equal to destination, then return true. Okay, now let's create the map. So I'm going to create the map here. The key will be map and key will be int, and then value what will store in a map is array of int. So for 0 I will store 1 and 2, so I will store that as a list or array. So that's why I create the map here in the, and then iterate through these edges. So it's a for, let's say I equal to 0, I less than length edges. So length is, for this edges length is 1 and 2 and 3, so 3 lengths. Okay, 3 lengths, and then I plus plus. So the first time, you know, we'll get 0 1, so we'll store this 0 in a key. So I will use the map here, so map and the key. So in this bracket I have to put the key, and if I say the key, so what is this key? That means this is at this 0 index, that means I index. So I index of age, so I can say age edges and I index. So I is 0, so it's a 0, and then I need this first item, so 0 and 0. So here I want to store this. I want to store the value. So value is a 1. So for first I got the 0, so this is the 0 value I got with this, and then next thing is I will store this 1. So before storing 1 there, I will check if there is any array list at that index or not. So if I use directly append, and here I can say m, and the same thing if I put here inside this bracket, that means if, you know, if it exists, like if the list exists, if there is some item exists at 0, then we'll get that item, and on that item I can append and I can add this 1. Okay, so for adding this 1 I can say this 1. So in that way, you know, I added this 0 as a key and this as a value in a list. So in the similar way, you know, I goes through this, all this item here 1 and 2. So in that way we can store this 1 as a key and other as a value. Okay, so our map is ready here. So that we store, you know, 0 as a key, so in this direction. So we also need to, because we know this is a bi-directional, so we also need 1 as a key, and we have to say that, okay, for 1 0 is 1 to 0, 1 age, 1 to 2 another age, so we have to store that value also. So let's copy this, and this time I want to store this 1 as a key. So I will be there for this first block, and then if I go here I can say 1 and then append. So in order to append, first I want to check if there is any item in a map for that particular key or not. So I can say 1, and I want to store this 0 as a value, so 0 as a value. Okay, so our map, you know, our graph is ready in the map. So in a map now, the map contains, you know, 0, like contains from this 0 to 1 and 2, so that's it, contains the list. So that's ready. So next thing is we'll create a queue. So let's create that. List.new. So our queue is ready, and in the queue first we'll add this item, or not this item but source, whatever is the source, we'll add that. So let's add that queue dot goes back source. We added the source here, and now we know we have something in a queue. So we know in a braid starts we have like we get one outer loop, and we'll check if the item is in queue or not. So let's have one outer loop for queue dot length not equal to 0. So that's one outer loop, and when we know there is an item here, and we also know when we traverse this from here to here and here to here, and again we'll from 1 again we go back to 0 and 2. So this we can reach to the vertices again and again. So that's why we have to maintain some visited boolean array. So here we can mark if we visit some node, then we can mark it true. So for that, let's create one boolean as a visited make so bool, and the size is n. And by default all this value will be initialized with the false, so all visited is false. And we know we put that in a queue, so we consider this as a visited. So I can put like visited source equal to true. So this first node in this graph 0 is visited, so I put that in a visited here. Okay, so in the if you traverse this graph and if you visit source and the destination, then we have to return true. So that's why let's create two more variable, is source visited and is destination visited, make it false. And we can also check here the source, like we know that this source is visited. So if that is true, we can check here, like if visited source, if source is visited, that means we can say okay, this is true, so visited. And we know that source is visited here, so that's good here. Another thing is we maintain this these variables here, and let's come to the queue and get one item out of the queue. So we'll get 0 out of queue, because we know we have stored 0 in the queue. 0, or just consider the 0 here if it is source, because source is 0 in this example, but it can be anything, it can start from any vertex. So whatever the vertex comes, we'll put that in a queue first, and we'll mark it as visited, and we'll start our journey from that node. Okay, so that's good here. Let's get out one item from the queue. So element queue dot remove queue dot front. We got the item, this element, and it's a vertex, so we can say okay, vertex type int. So we get one vertex out of this queue, and then what we do, we use this vertex and get the items from a map, because we know for the 0 we have stored 1 and 2 in a map. 1 because 1 and this 2. So we'll use another loop here for vertex list range and map. From map we want to pass the key, and the key is vertex. So we got the key here. So in the key, when we pass 0, then we'll get 1 and 2. So we get 1 and 2, and we'll check here if that is visited or not. If it is not visited, so we can check condition if okay, so wait a minute. So if when you put the aim and vertex, then it will, that's a list, so we'll get the item one by one here. So let's say this is v, so I can check if visited v is, you can use like not. If it is not visited, then come inside, and if it is not visited, so for 0 we get 1 and 2. So we know that 1 and 2 is not visited, so first put that in a queue. So queue dot pushback v, and when we push back to queue, we say that that's a visited, so mark it visited. So visited v equal to true. So in the same way, in the similar way, if you traverse, we know that if the we sometime like we reach to destination, and if you reach to the destination, we'll make that variable also true. So here I can say if visited destination, if the destination is visited, then we can say okay, is destination visited equal to true. And we have already marked the source true, so we know that we're starting from that source, that's a true. And sometime if the destination is also visited, then it's a true. And then we can add the conditions if source is source visited and is destination visited, then return true. Otherwise we can return false. So this is come outside of this queue and return false. So let's run this and see for the syntax another error. Okay, so we need this bracket. Let's run once again. Accepted, and try to submit. Okay, that's good. Yeah, so that's all for today.